Thank you all for joining us today. On your screen is Ted Allen, and he is the Vice President of ETemplate Systems. He has been with the company since 2014, and he has his degree in computer science and has been working early jobs in construction before and during college. So he is well versed in construction and stairs. So also with him today, you might see him here and there, is Art Mealer, and Art is their support and training specialist, and he has a long career there with ETemplate Systems and is available for any of your questions as well. So with that, Ted's going to take it away.
All right. Thank you, everyone, for having me today. We want to be able to do an overview for you on things that our clients say that they want to see and that they want to do when they come in for training. So we're located in our training center today. And what we have here are some adjacent walls, so just adjoining. We also have some marks up at the top of this wall over on this side that actually are points that we may use as connecting points to shoot. We also have a set of stairs here, and this is just, so that we can show a few different things when we're in training and clients want to see, how do I capture radiuses? So we have radiuses here on the front of the stairs, also wraps around at the base of the stair. Radius stairs here. So we've got about 3 or 4 different levels that we can do so that we can show the treads, we can show the risers. We can also show the stringer on the side of the staircase. If that stringer is transitioning radiuses, we can show that. If we have a larger staircase, we can do that. And then the last thing that I thought we could show is just occasionally we get people that want to be able to do railings. So they may be doing a railing system for a staircase, whether it be straight, radius, or whether they're doing a balcony and need the same thing. So they want to be able to capture the space for the panels, or if they're doing glass panels for that particular staircase, they want to be able to capture that information as well. So we'll transition to that. Okay, so let me get back behind my computer here. Okay. And I'm going to minimize this particular video. And I'm going to show the actual system video, because what I have in the use of my, my system that I'm using here, just real quickly, I have the 3D disto from Leica, which is working in conjunction with Measure Manager software from it allows me to do several different things, but I can move this hand manually, or I can move it either by motorized control or with a remote control that comes with the system. So there is a remote that allows me to move the head as well. And what that allows me to do is target on certain areas of a staircase or any other point that I have. So if we're looking at that, right here, I can see that my crosshair is the center of my laser beam. So if I'm wanting to shoot to the front of the staircase, I can simply find my points and take points along that curvature. Also, for areas that I cannot see, you see that I've got these markers set up back here. And these edge markers allow me to actually reference the back side of that same curvature and take those, so that if I'm in position and can't see it, I can shoot those points. My other option is to use the offset tool, which is here, which allows me to capture one point on this side, one point on this side, and then wherever it is touching the element behind where I can't see, it will capture that point. So I have a couple different ways to do that if I don't want to move the laser. If I want to move the laser, the system is completely relocatable. So I can take 3 to 5 secure location points, pick the laser up, move it, recapture my secure points, and then continue measuring. So that's very helpful if I'm measuring multi-tiered or multi-leveled staircases, or if I'm doing a radius or a curved staircase. You definitely have to be able to move your way around so that you can capture the full extent of that staircase. Okay, so Over on this side of the screen, we have our Measure Manager software, and it consists of the toolbar, or measure toolbar. So I can measure lines, arcs, circles, freeform curves, rectangles. I can also check level on flooring. I can take points and 3D points, my planes and datums and depth tools, and then head communication. And then down below, I have a full CAD assortment built on top of CAD software, so that I can edit, notate, draw, create whatever I want to in this particular screen. Down below, what I've got is just kind of a lead up to this particular setup that I have here. And this just allows me to give you an overview of, what you can accomplish by taking points out in the field with the system. So if I want to capture the radiuses, I can capture those, do it through point taking and also the stringer, along with the railing system up the wall in a 3-dimensional space, and also be able to take points on a plane. So if I want to know if the wall is plumb, or if it has high points or low points, if it's leaning back at the top or at the bottom, I can determine that by shooting points and then using our wall analysis feature. Then the 0 indicates the high point of the wall, and it shows that I'm 1/8 below that point in 3/32 here. So if I have a series of those points at the top part of the wall and the bottom of the wall, I can see what that wall's doing. Okay. All right. So let's go in and let's do a little bit of a measure. And once we're done with the measuring, I'll queue up a video. And then after that, we'll field some questions. Sound good? So let's create a new file. And the first thing we're going to do is actually set a datum. And I'm just going to pick a datum to shoot on this back wall. So the same wall that my railing is on, I'm just going to take a couple points. Okay. And the next thing I want to do is create a working plane. So I want to create a plane that is parallel to my datum. And right now it thinks that the plane is around the laser head at the same height. So I'm going to actually aim at the floor. So I'm taking a point off the floor to determine that. And that transfers my working plane to the floor. Okay. Now I want to lay out my space or the adjacent walls. So I'm actually going to do a floor plan. So in this case, I'm going to take 2 points per wall and just create lines for the floor plan. Now, if you're out in stud phase in the field, you can take a point on every stud and it will allow you to draw a line based on points on the studs. If you have studs that are kicked out backwards, forwards, you can offset to either a high or a low stud if you want to do that as well. For practical purposes, we're just going to take 2 points per wall. So we'll switch to our line mode. And we'll take a point over on the far left. And now I'm going to take it in about 2 inches from the corner. Transition to the next wall. 2 inches from the corner. And go to the end of that wall right there on the right side. Okay. Well, what that gives me is I have 2 adjacent walls, just a 2D view. So I want to join those walls, so I'm just going to trim those up. And then I'm going to change my view to an isometric view. Give this a little rotation. And I'm going to go and establish a height for my particular space. So I'm just going to go next to the depth tool, which is right here. From here, I'm going to aim up with the laser, and I'm actually going to go up to the ceiling. So right now I'm pointed just at the ceiling towards the corner. Okay. What it does is it takes that depth, 107.244, and it stores it in the clipboard for me right here. Okay. And now I want to extrude that particular space. So I've selected it. I'm going to enter it as my Z value. And voila, I've got my two walls ready to go. So now I've got my space predetermined. So now let's just say that I want to have some connecting points on, say, this wall panel here. So if I want to do that, then I need to be able to establish that as my working plane. And I can switch to that for a plane. As so. So now this wall has become my working plane from the floor. And I want to go and take a series of points. And I'm going to take these as 3D points. Now up top, I've got 3 marks. So I'm just going to aim as closely as I can get here, just for practical demonstration purpose. Okay, so now I've got those 3 points on the wall that are my connecting points. And let me rotate that just a little bit. All right, so if I wanted to determine if those points are high, low, if that wall's tilted back, I can actually take a few more points. So I'm still in point taking mode, and maybe I'll just take a couple more points down here towards the middle of the wall. Okay, and in doing so, now I want to analyze that data. So I'm going to draw a frame around that, and I'm going to go over here to my plane analysis tool. And what it does is it comes in here, and I've actually laid these out backwards, but it tells me that 0 is my high point on this particular wall. And at the top, I'm an eighth back, 7/32 and a quarter. So with that, we know that the high point is towards the bottom of the wall. So it's probably going to be even more towards the bottom. Okay, so I can gather that information pretty simply. All right, now I want to go back and just change my plane to the floor again. So I just click on 2 adjacent walls. It transfers the plane for me. And I want to go in and I want to capture the radius for the stairs at the bottom of this. So if I want to show the radius that I'm looking at on the bottom of the staircase, and let me pull up the other video real quick. So here, I'm going to be trying to capture the shape of this bottom that wraps around to the back. So let's do that. And we're going to do that with our spline tool. We're already set for the floor to be our plane. So let's go in and capture that as a spline. And we start taking points anywhere on that surface that we want. And I'm just moving every 3 or 4 inches. And then since I can't see the back, I'm going to go up to my markers. Okay. Now I can also use the crosshair, and I can use the video for targeting. It allows me to zoom in. So if I'm in proximity, I'm about probably 8 feet away from what I'm shooting right now. But this system will allow me to shoot 30 feet, 40 feet, 50 feet. It actually has a range up to 160 feet. You're going to maintain about 2 to 3 millimeter accuracy at about 100 feet. And you're going to have about a millimeter of accuracy at 30 feet. So as you're aiming, visual acuity does come into play if you are targeting by eyesight. So that's typically about 20 to 25 feet. So anything beyond that, having the capability to actually shoot and use the video is paramount for capturing and maintaining precision in the measure. That's why the system operates so well. Now next, since we've already taken all the points for the spline, I'm just going to hit enter, and it's actually going to draw that spline for me. So let me just show everyone real quick what that spline looks like on the floor. So I've captured that radius for that particular staircase, okay? And now what I want to do is I want to extrude that after I turn it into lines and arcs. So if we grab that spline, and I'm just going to highlight it here, now I can actually convert it into lines and arcs. And we know why we want to do that, right? Because CNC doesn't cut a spline. Make sure. Make sure that I got this conversion right, guys. Give me just a second here. Hey, Art, can you look at this for a second? Yeah, I just want to make sure this spline got converted into arcs and lines.
So spline, we're going to hit accept, escape. Then we're going to go back and find this. It needs the spline there. We're just going to get rid of the spline. That's
there we go. There we go. Thank you, Art. Sometimes I need the trainer too. Okay, so clear that. And if we go in and we highlight the spline now, we can actually delete it. And it will leave the arcs and lines version on the floor. So this is the version that we need. Okay, so we'll zoom back out, and we're going to extrude this to the height of the next step. So if I go in next and change my plane, I'm going to pick a height for this particular extrusion and go here from the floor. So I'm on top of the step. And I'm going to extrude that particular item to that height. Okay, so now I've got that in 3 dimensions. So the next phase of this is we'll go up to our next plane. And this is going to become my working plane, the top of that staircase. Okay, so I've transferred plane and I want to go ahead and capture that backside radius of that stair. So on this, I'm going to go to my arc tool and capture that backside. I can do this with the arc tool. I can do this with the spline tool. Okay, and I can also do my lines up on this level as well. So if I want to capture the other side of that. Okay, and then from here, I want to be able to capture a 3D line. Okay, and I want to extrude that particular radius up to the next level. So my working plane is that first step. I'm going to go up to the next level. And I'm simply going to grab my radius and I'm going to extrude it to that level. Okay, and then we'll switch planes again. And then next level becomes my working plane. And I'll repeat again with my lines. And my radius. Okay, and we'll also capture the radius on the side here because this is a beginning radius for this particular staircase. Okay, so that gives me quite a bit of data so far on this particular staircase. So if we rotate this, kind of come in and see what we have so far is the three-dimensional model of the staircase. Now, in some cases, I've had guys that have asked me if they just want to take points on the front edges or front corners of the staircase, if they want to offset a certain distance. They can use the markers to do that as well if they're bringing a railing system down and they want to know the connection points or where their balusters are going to come down. They also want to know just the radius of this turn. They can capture just that radius if they want to do that and just have it projected to the floor so that they know what the radius is. So there's a variety of things that you can capture as you're doing this very simply. Okay. So let's go and transition from here and go to the rail on the back of the wall, since we're running in a little bit of time, trying to keep you guys quick, and I want to get to a video towards the end. let's do a real quick rail system on the back side of the wall, and then we'll talk a little bit more, and I'll queue up about a 3-minute video of an actual job and an existing site that they had to build a staircase to. So I'm going to get Art to jump over here and take over driving for a moment, and I'm going to walk out front. I'm going to switch video.
I'm going to grab a new sheet of paper. And you want the video on here? For which? Oh.
There you go. Okay. So we'll do, over here, we'll do the rail, and Art's just going to show from a classroom point of view. We've had several people come into class and they want to be able to understand the best way to shoot a rail or how to shoot a rail or different methodology for practice. And that's really what we do here in the training center is we allow people to get that good hands-on practice that they need in order to get better at using the system. You guys have the skill sets. You know, you're the tradesman and you know how to do your job better than we do. So what we want to try to do is help this tool that we sell become a significant part of making that process better for you, saving you time, enhancing the accuracy, and making the overall job better. So, Art, you want to jump in on that?
Sure. So, by the way, thanks everybody. I'm going to take, I want to capture this data, the as built, so we can come back to the shop and manufacture this. First thing I'm going to do is I'm going to create a construction plane that's on this vertical wall. And let me switch here in the camera view. So I'm going to shoot 1 point to the left, 1 point to the right, 1 point vertical. Those 3 points define that vertical construction plane. And you'll notice our little note here says datum processing completed successfully. So now I can draw what's on that wall on my sheet of paper for you. So I'm going to begin by shooting lines to capture again that as-built data. And I think it's better for me to show you. You know what it looks like. You've been seeing it. Let me show you where the laser's pointing. So I'm going to first hit a straight line on the inside of that post. I'm going to come underneath the handrail. I'm hitting the intersecting plane to capture the ending of that run. And then I'm simulating hitting a stringer maybe. And down along here. All right, so let's trim that up on our drawing. I'm using a smart trim tool. It makes you look smart. All right, so there we are. One of the things I'm going to need to do now is this is the actual space, so I've got to make some room for the glass to sit underneath that. So I'm going to go to this chain offset. I'm going to offset it by 1.5 inches. And I'm going to go from here back to my chain offset tool. 1.5 inches, okay. Selection not on the construction plane. So using a line tool. Well, yeah. So I'm going to do it manually. We'll go with this offset tool here, 1.5 inches. If I use a chain tool, I can do all 3 at once, but it's not letting me play. So we'll do it the slow way. All right. I don't need to move this stringer on the bottom. That's fine. I'm going to go back to my trimming tool again. So that represents where I'm going to need to put the glass. And we also have on the wall, yeah, a couple of locations for mounting points. So I'm going to hit that. I'm going to use the circle tool, collect data about a circle. There's 3 points around that circle. And so you can see the mounting plate. So I can collect any real world data that I need to as built, take it back to the shop, and then manufacture these. I may want to put 5 or 6 panes here, offset these lines, trim them up, however you're going to design it. But I can come back from the shop now, from the field to the shop with the actual as-built data.
Okay, thank you, Art. So now I think what we'll do is we'll queue up just a little 3-minute video, and it shows more of a real-world example of what someone did with a staircase. So let me move a couple of items, and we'll bring up the video.
So this is another interesting project that we found a lot of success in using the laser to gather information. This is a staircase that's going in what used to be a mall, which is now a school. They're expanding the school, so during the summer, we have a very short window to build this new staircase in an existing building. As you can imagine, this being a mall, a former mall, and now a school, the structure is extremely important. Structural issues are extremely important. So what we were able to do is actually go in and shoot our structural points with the ETemplate laser system, so that we know that what we build in the shop, we can take out in basically 2 pieces, almost fully finished, and set them in place and then fit just like they're supposed to. So this is actually the area that the staircase is going in. Where this gentleman standing here, the staircase goes up to this wall, it turns, and it goes up to this window right here, which will actually be a door. So obviously this is a little bit intimidating when you look at this and you go, okay, I have to swing a staircase into this area. I don't know where any of the structural is. I don't know any of this stuff. So I'll show you in the next picture how we accomplish this with the ETemplate system. So what we asked the general contractor to do was open up very specific areas for us that we could actually physically shoot with the laser the structural steel that's existing in the walls. Therefore, we could reverse engineer our staircase and get it signed off with an engineer and know exactly what's going to happen when we got there. So this was actually another multi-stage shoot where we went out and basically picked a couple points that were going to be our benchmark points for this whole job, no matter how many times we went out to shoot this area. So we shot it, I want to say I shot this 2 times as we were developing kind of a design build staircase here. So again, having to do this without the laser would have been very complicated, time consuming, and nowhere near as confidence inspiring as where we are now. And we'll take you out to the shop and show you the physical staircase that we're building.
So as you can see, we're building the staircase pretty much to completion. So when we go out to the job site, these 2 pieces will basically just pop together. And I love to make it sound that easy, but there's no way we would ever try to take it this far in the shop if we didn't have the confidence that we have with having taken the laser out on site and knowing that the points that we're going to hit here and the points that we're going to hit in the back of the stair over there are going to hit the existing structural just right. This gives us the efficiency to take this as far as we can, which is almost all the way. And really just by the time we get on site, we're going to put it together, we're going to weld it together, we're going to drop the corrugated in the landings, we will do some touch up, and we'll be able to walk away within 2 days. So that ability is priceless to us, and it has raised our profit margin by an extreme degree.
Okay, so that really brings us to the end of our presentation today. We want to reiterate that with the system, you can measure on different planes, different shapes. Doesn't matter, what you're shooting at within proximity. If you can see it, most of the time you can shoot it with the ability to capture that data, take that data, send it back to the shop, let the shop pull it into CAD, and you're going to get your data in DXF, DWG, It also does IGES. So the system's a great fit for the stair industry. We've had great success with that. That was Heirloom. They bought the system years ago and have been enjoying it. And we've got additional customers throughout the country. And you know, we love that industry. So hopefully we can help additional people out there that are listening with the system. If you do have questions on the system, feel free to email us at info@etemplatesystem.com, or you can call us as well at 919-676-2244. So thank you very much. Anybody have any questions?
Thanks, Ted. Thanks, Art. So if you have any questions, feel free to unmute yourself and go ahead and ask those. If you don't want to ask and you want to put them in the chat, you can do that and I'll ask them for you. So are there any questions?
I'll just say it changed our program dramatically. We were actually down there, measured that little stairway there, a couple of days of training. It was a great time. It's been huge for us. We debated it quite a few years and finally took the plunge, and glad we went with your system. And it's one of those tools that now we'd cry if we had to do without it.
Thank you so much. I appreciate that. Any other questions? I think Art wants to say something here real quick too.
Yeah, if you were watching, you saw both Ted and I ran into a little glitch as we were going. That happens to everybody in the field. When that happens to you, you get out your phone right from where you're at, you give us a call, and somebody answers the phone, myself, Kevin, Paul, and we work you through whatever it was, just like Ted and I did for each other here. So
absolutely.
Word for tech support.
So
that's awesome.
That's a great point, Art. And we do that all day long for people that either get stuck or have a question or want to do something that they haven't done in the past, or they just need us to jog their memory a little bit. So it happens all the time.
Awesome. Well, thank you both so much. And thank you everybody for attending.